topic polar curves. So before studying polar curves, I'll go here, I'll recall Cartesian curve. Cartesian coordinates. So here I'll draw the graph. Here this is x-axis. In Cartesian coordinate you will get in the form of x comma y. So here this is x-axis and this is your y-axis, right? Now suppose they given 2 comma 3. So 2 comma 3 means you will get here, this is x value is 2 and y value is, you will get 3. So you can plot the graph here. So this is your Cartesian, right? So this is in the order pair 2 comma 3, right? Now I will take here x-axis and here y-axis. So I will point out some point P of x comma y. I am taking generally. So here I am taking here, I plot the graph. I will join from origin. So what do you get now? So this becomes now here, I call it as the O and I call it as this one as L, and here it is P. Now it is made an angle theta anti-clockwise and it should be an 90 degree. So what are the radius is there? So I call it this one as R and this one is perpendicular, right? I will take this one as Y and here I call it as X here, X axis. Now what I get here, what I get sin theta, sin theta pi by r, that means PL divided by OP, PL divided by OP. So this becomes, what I get here, pi equals r into sin theta will get. Now what I get here from the figure, what I get cos theta can be written as x by r, means OL divided by PO. So that means x by r. So that implies that x is equal to r into cos theta. So what do you get? Y in terms of r and theta and x is also in terms of r and theta. So that means P of x comma y, you will getting new coordinate system, that is here I call it this one as P1 of r comma theta. In terms of r comma theta you are getting new coordinate system here. So that P and r and theta is called as polar coordinates. That is called polar coordinates. So remember that one, r and theta are called polar coordinates. So this is x and y are the Cartesian coordinates and r and theta all are polar coordinates. So you know how to plot the graph for Cartesian. Now we will check how to draw for polar coordinates. How to plot the graph, how to plot the graph for polar coordinates. So polar coordinates means in terms of what I get, r and theta, in terms of r and theta. So suppose they give an example, it is 3 comma 60 degree. 3 comma 60 degree. So in polar coordinates, this is called as theta radians here, that means 0, and here that is theta equals pi by 2, and here it is pi, and this one is 3 pi by 2, and again if you come it is 2 pi, means 360 degree. So here what do you get? This one in Cartesian it is then called origin, but here it is pole, and this one is x-axis, and here this is called as initial line, and this one is y-axis, and this one is called an perpendicular line. This is short form for perpendicular. Okay, so remember that one. So this is perpendicular line, and this is pole. 0 comma 0 is the pole, and here this is the initial line. So I want to plot for 3 comma 360 degree. So theta is 60 degree and r is 3. So what do you get? This one is r is equal to 1, and this is for r equals 2, and here r equals 3, right? So r equals 3 you get, and here what is 60 degree? So from the pole you have to write 60 degree, means below in between 0 and pi by 2, right? So this is your 60 degree. So now second one, I'll take another example. Here 2 comma 3 pi by 4. 2 comma 3 pi by 4. So what I get here, r is equal to 2 and theta is equal to, they given 3 pi by 4. So you have to convert into degree. So you have to multiply this one into 180 divided by pi. So pi will get cancelled, and here it get cancelled, 64 is 16, and here 45 degrees. So we'll get, if you multiply, you'll get 135 degree. So what do you get now? This is theta 0 or 2 pi or 360 degree, and this one is pi by 2, and this one is pi, and this is 3 pi by 2. Now what is r? R is equal to 2. So r is equal to 1 for this one, and r is equal to 2. Now what do you get? Theta is 135 degree. 135 degree means in between pi by 2 and pi. So you will get here. So it is 135 degree. Suppose if you get negative. Suppose if you get negative. So here minus 2 comma, what do you get? 60 degree. It is 60 degree. So what we'll do here, this is theta is equal to 0 or 2 pi, and here theta is equal to pi by 2, and here it is pi, and this one is 3 pi by 2. So r is equal to minus 2. So here r is always positive, because it is radius is always positive. You will not get negative here. So you have to convert it into positive way. So what do you get here? What do you get? You have to find out the 60 degree. 60 degree, what do you get here? In between 0 and pi by 2. But r is negative, right? So you have to convert it into positive. So that time you have to add 180 degree for this one, 60 degree. So 60 plus 180 degree. So how much will you get? 0, and 4, and what you get here 14, 4, and you'll get 240. So 240 means between 180 and 270 degree. Between 180 and 270 degree you will get here. So it is 240 degree. Now r is equal to minus 2 is become positive way, so plus 2 will get now. So r is equal to 1 and r is equal to 2. So like that you have to plot the graph. Now I will go for polar coordinates. Polar coordinates. So here I'll draw one line, so that is 0 to L. So start from 0 to L, so this is called an initial line, and 0 is called an pole. So what do you get? A line OL drawn through O is called initial line. And here I plot one coordinate here, P of r comma theta, any point on the plane. So what do you get here? If P is any given point in the plane, so what do you get? I will join these two. Join the O and P. So here what do you get? The length OP denoted by r. So I will call it this length as r is called the radius vector. Of the point P, and the angle LOP, this anti-clockwise theta, okay, angle LOP denoted by theta measured in the anti-clockwise direction is called the vectorial angle. So the next line, the pairwise the pairwise r and theta, the pairwise r and the pairwise we can write r and theta represented or represents by p of r comma theta as shown here is called as the polar coordinates of the point P. So one condition here. So what is the condition? R is always positive and theta lies between 0 and 2 pi, means it is 360. So next here, relationship between the Cartesian coordinates x comma y and the polar coordinates r comma theta. So I'll draw the figure first. So this is your 90 degree and here angle theta here, so it is O, and here I will write relation between whatever Cartesian coordinates and polar coordinates. So P of x comma y and P of r comma theta at the same point I am taking here. Here I called this one as r and this one as perpendicular y line, and here this is x-axis line, so I call it as x here. So let x comma y and r comma theta respectively represent the Cartesian and polar coordinates. So here from the figure we have what we get, I call it as O and I call it this one as Q and this one as P here. So OQ equals X and here PQ is what I have defined, I will define that one as Y. Also from figure the right angle right angle triangle. So what is right angle triangle? OP, OQP or PQO. So OQP, we have cos theta equals, cos theta can be written as, what do you get, OQ divided by OP. So that is nothing but, what do you get, X by R. So this implies here, what do you get, X is equal to R cos theta. Take it to left hand side, so we'll get X is equal to R cos theta. Similarly, what do you get, sin theta equals, what do you get, QP divided by what do you get, OP. So what do you get, Y by R. So this implies Y is equal to R sin theta. So this one take it to left hand side, so Y is equal to R sin theta. So I equal to this one as 1 and this equation as 2. Now here squaring equation 1 and 2. So what you get here, if you add equation 1 and 2, x square is equal to r square into cos theta. So I got as equation 3. So if you square this one, y square is equal to r square into sin cos square, and here sin square theta. Called this one as equation 4. Now add equation 3 and 4. So adding equation 3 and 4, we get here, what do you get, x square plus there you will get y square is equal to, what do you get, r square into cos square theta plus r square into sin square theta. So if you take it r square common, so what do you get, x square plus y square is equal to, if you take it r square common, what do you get, cos square theta plus sin square theta. So what is cos square plus sin square theta? It is 1. So what do you get, x square plus y square is equal to r square. So r is equal to square root of x square plus y square. Now you have to find out now theta. You find out r value. Now you have to find out the theta value now. So now here dividing equation 2 by equation 1. So we get equation 2 divided by equation 1. So what you get here? So r sin theta divided by r cos theta is equal to y by x. R get cancelled, sin by, what you get here? You get tan theta is equal to y by x. So theta equals, what you get, tan inverse y by x. So these two are the relations. So you have to convert to polar form, means first you have to take x is equal to r cos theta and y is equal to r sin theta. So we get r is equal to x square plus y square and theta is equal to tan inverse of y by x. Okay. Now next here, angle between radius vector and tangent. Angle between radius vector and tangent. So first I'll draw the figure. So here this is, I have called this one as L, and here this curve is equal to R is equal to f of theta, and here you will get an phi here. I have called this one as theta, and here this point is called P of R comma theta, polar form point here. Now here this is the tangent, this line is tangent, remember that one. So let P of R comma theta be any point on the curve R equals f of theta. R equals f of theta. From figure xi, here I got this angle is psi. Okay, so xi equals phi plus theta, because exterior angle is equal to sum of the interior opposite angles. So what are the two angles? Theta and phi. So xi is equal to phi plus theta. So you can write that one from the figure. So now I will apply tan on both sides. So tan xi is equal to tan phi plus theta. Tan phi plus theta. Now here what is, you have formula tan A plus tan B formula. So what do you get? Tan A plus tan B formula. Tan A means tan phi plus tan theta tan B divided by 1 minus tan A into tan B, means tan phi into tan theta. So this is tan xi only. So I will call this one as equation 1. Okay, now I will consider Cartesian form. Here same point for Cartesian P of x comma y. So let x comma y be the Cartesian coordinates of P, so that we have x is equal to r cos theta, y is equal to r sin theta. So here, and now I'll consider here tan xi. We know that x and y here. So tan xi equals slope, right, dy by dx. That means what do you get? Slope of the tangent. So this is slope of the tangent. Now slope of the tangent. So this can be written as tan xi can be written as, here x and y are the terms of r and theta. So what you get? Dy by d theta, functions of r and theta here, r and theta. So this can be, dy by dx can be written as dy by d theta and dx by d theta. So what you get? D by d theta into what you get? Y is, what you get? Y is r sin theta divided by, what do you get, d by d theta, what do you get here, r into cos theta, because x is r into cos theta. Now differentiate with respect to theta. R is a function of theta also, so you have to apply product rule. Here also you have to apply product rule because R is a function of theta. So what do you get now? So R into cos theta, R into differentiation of sin theta is cos theta, plus dr, R is dr by d theta. So dr by d theta can be written as R dash into sin theta, whole divided by, here also you have to use product rule. So what do you get, R into differentiation of cos theta is minus sin theta, plus here R becomes R dash into cos theta, where R dash equals dr by d theta. This represents. Now dividing both the numerator and denominator by r dash into cos theta. So we have what do you get here, tan xi equals both numerator and denominator, so r into cos theta divided by r dash cos theta, plus what do you get, r dash sin theta divided by r dash cos theta, whole divided by what do you get here, minus r into sin theta divided by r dash cos theta, plus r dash cos theta divided by r dash cos theta. So these two get cancelled, and here cos theta and cos theta get cancelled, so r dash will get cancelled. So what do you get here now, r divided by r dash plus sin by cos is tan theta divided by, first I will write here 1 minus here r minus r dash into, what do you get, this 2 becomes tan theta, sin by cos is tan, here r I written here. Now compare with equation 1 and equation 2. Compare equation 1 and 2. So it is tan xi. So it is tan xi is there, and here tan theta is there, and here also tan theta is there, and here also 1 is there, minus is there. So in place of xi, what is there, r divided by r dash in both the side, here also. So what do you get, by comparing you will get tan xi equals r divided by r dash. Now what is r dash? R dash here you can write as dr by d theta, so substitute that one. So tan xi equals, what do you get, r divided by dr by d theta. So take it up reciprocal there, so this can be written as r into d theta by dr. So take it reciprocal, 1 over tan phi equals 1 by r into, so this can be written as dr by d theta. So if you take it reciprocal you will get like this, d theta by dr, so dr goes to upwards here, numerator. So this can be written as cot phi equals 1 by r into dr by d theta. So this is very important, either you have to remember this one or this one or this one. So we will use in the problems, very important. Now next here length of the perpendicular from the pole to the tangent. Length of the perpendicular from pole to the tangent. Now here I'll draw the figure first. So we will draw one curve. So you have to draw the tangent for that one. So that is here, you join here, so this becomes, it is an 90 degree, make it. So this is your theta and this is your r, and this one I call it as phi, and here this point is p of r comma theta. So I call it this one as L and here N. So here from the figure ONP, from the figure I called this one as ONP, it is an 90 degree. So and LOP, so LOP is equal to, I call it as here LOP, this point is P, so it is an theta. So now from the right angle triangle, from the right angle triangle ONP, from the right angle triangle ONP, so sin phi can be written as ON divided by OP. So this can be written as P by R. So if you take it here, what you get, P is equal to R sin phi. So you have to remember this one also, you will use in the problems. So we have what you get, P is equal to R sin phi, right? So if you take it reciprocal, squaring on both sides, so what do you get here, P square is equal to R square into sin square phi. So take it reciprocal for that one, so 1 over P square is equal to 1 by R square into 1 by sin square phi. So if it so what you get, 1 over P square is equal to 1 over R square, so this can be written as cosecant square phi. So cosecant square phi can be written as 1 over P square is equal to 1 over R square into 1 plus cot square phi. But we know what is cot phi. Cot phi is 1 by R into dr by d theta. So substitute there here. So what we get, 1 over P square is equal to 1 over R square into 1 plus 1 by R square into dr by d theta whole square. We know cot phi, this is cot square phi, so we have to take it squaring. Now 1 over P square is equal to, what you get, multiply by 1 by R square, so you get 1 by R to the power of 4 into dr by d theta whole square. So you have to remember this formula. Okay, now so next one, angle of intersection of two polar curves. So So I'll write the drawing first. So here from this point here I consider one curve and I consider another curve. So here this is the tangent, and for this one, this curve, this is the tangent, so I'll call it as T1 and I'll call it as this one as T2. So I'll call it this one as L, it is in theta, so it is O, and here this point is PL taken. So I'll take this one as phi 1 and this as phi 2. So here let R is equal to F1 of theta and R equals F2 of theta be two curves intersecting at the point P, So from the figure, the angle between the two tangents is equal to phi 2 minus phi 1. Therefore the acute angle, you will get here acute angle of intersection of the curves is equal to mod phi 2 minus phi 1. So always you will get a positive value, that's all. So if mod phi 2 minus phi 1 equals pi by 2, suppose if we get pi by 2, then we say that the two curves intersect orthogonally. So here if phi 2 minus phi 1 equals pi by 2, then phi 2 equals pi by 2 minus phi 1. If we get plus phi by 2, if you take it to right hand side, then here I will apply tan on both sides. Phi 2 equals tan of pi by 2 plus phi 1. So this can be written as minus cot phi 1. Tan pi by 2 plus theta is minus cot theta. So this can be written as here minus 1 over tan phi 1. So this take it to left hand side. So what you get, tan phi 1 into tan phi 2 equals minus 1. If you prove this one also, then we say that the two curves intersect orthogonally. So write on the formulas on one side here. Okay, take it separate sheet and write on the formulas. I'll continue next class.